So we're going to be doing lesson 7.1 in your algebra book. We're going to be talking about compound interest. So the big idea, compound interest is the way that most banks and other savings institutions pay savers who put money into their accounts. Compound interest is also the way that credit card companies charge you interest. Okay, so this is actually a very practical unit and something you will definitely be using and encountering in the future, regardless of whatever your career is. If you take out a loan, if you take out a credit card, or if you invest money in a retirement account or in any other kind of accounts, you're going to have to deal with compound interest. So it's a very practical unit and something I think is very interesting to study because it's so realistic and applicable to your life. So we're going to start with these definitions. They're all really important, so we want to use them. So a power, we kind of know what this is. We've dealt with them before, but it's a number in the form of x raised to the n. So that's a power. So we've got exponents going on here. We've talked about exponents obviously a lot. And so anytime we have something in this form, we call this a power. And what this does is it describes repeated multiplication. So instead of writing 5 times 5, we can write 5 to the second. Repeated multiplication can be expressed as a power. So there's two pieces to this. So when you have x raised to the n, the base is x. So when you have 5 squared, 5 is the base. The exponent then, when you have x to the n is the exponent. It's what you're raising the base to, and it tells you how many times the repeated multiplication is happening. Okay, so now we're going to be talking about specific terms that are going to be used in our interest formulas, and they're all things that factor in to our interest. And so principal, this is going to be the money that you start with. So if you're investing, the amount of money that you originally put in to your investment, that's your principal. The interest is the money that you're going to get, and it's a percentage. So it's the percent the bank pays you or you pay the bank. It depends if you're the one with the loan or if you have an investment. All right, annual, that word means yearly, so every year, annually. The annual yield is like your earnings. So the annual yield, excuse me, that's the percent that your money earns every single year. So when we talk about your annual yield, it'll be a percentage, and it's how much of the money you're earning on your investment. All right, compound interest is interest paid on interest. What that means is, so year to year, you're going to make interest, or you're going to have to pay interest on your loans or on your investments. And let's just think about it as an investment for a second. You're going to make money every single year. That money then sits in the account, and you get interest on that money. And then as you make more money, that money is now in the account even more, and you're going to make a percentage of that. And so it compounds on itself, and it gets bigger and bigger. And that's how credit card companies make their money. You put a little bit on your credit card, you get a little bit of interest, but if you don't pay it right away, now you're going to get charged interest on that bigger amount. And that gets bigger and bigger and bigger, and you just keep getting interest on your interest, and it can get out of control. And so there's a formula for calculating this, and we're going to be using this for the majority of this unit. And so what does all of this mean? So A is kind of like your account or your total amount. So that's the amount of money basically. P, as you could guess, that's your principal. So that's the amount of money that you put into it, that you start with. R is your rate, which is your percentage, but it's given as a decimal. So if we're talking 10%, it's going to say 0.1 or 0.10. If we're talking 5%, it's going to be 0.05. So it's the percentage, it's the rate that you're earning or that you're paying, but it's not going to be written as a percent, it's going to be written as a decimal. And T represents time, but we're going to be using it as years. Okay, so T is time, but it's number of years. All right, so real quick, we're going to discuss our exponents, make sure we remember how the powers work. So rewrite each of the following using powers. We're going to count these up. We're multiplying the number 2, so my base is 2, and I'm raising it to an exponent. It's how many times I'm multiplying it times itself. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I missed the first one, 12. So it's how many times it's being multiplied here. So 2 times 2, where you see it twice, that's 2 squared. And if it was 3 times, 3 2s, that'd be 2 to the third. And so when you count this up, it's 2 to the 12th. Now this one, you can only put the exponent on the base that's repeated. And so 5 is just going to stay. The x is being repeated 1, 2, 3, 4, 5, 6, 7 times. So this is 5x to the 7th. And here we've got different bases. That's 4 to the 3rd. And that's going to be multiplied by 3 to the 5th. Okay, so it's important to know that you can't mix those bases together. They're separate. And we've covered that before. So let's jump into compound interest now. So flip it over. Example number 2 says, suppose you deposit $2,000 in a savings account. It pays an annual yield of 4%, so that's your rate. So you're going to get 4% added into your account every single year. If the account is left alone, how much money will be in the account after 5 years? So you can't just take 4% of 2,000 and then add it 5 times, because you're not just getting 4% of the original amount, you're getting 4% each year. So if you think about the first year, you're going to get 4% of 2,000. But now that money goes into the account. So you have more than $2,000 in that account because you got interest in there. And now that year, you're going to get 4% of that bigger number. So you're actually going to get even more interest now. And the next year, even more and even more, because this is growing and you're still getting 4%, but it's of that bigger amount that's in there. So that's how it compounds. And so it's going to be over 5 years. And so we're going to use this formula. And you'll notice it's 1 plus the rate. Now the rate's always a percentage. It's going to be the 4%. And if you add a percent as a decimal, so first of all, 4%, remember, is 0.04. You don't want to put 0.4, that's 40%. So 0.04, and if you add 1 to it, 1 plus 0.04 is just 1.04. That 1 represents 100%, and this is 4%. So this is 104%. So you're getting 104% on your investment there. It becomes 104%, I should say. So let's plug the numbers in. We're trying to solve for A. We want to know how much money we're going to have. The principal was $2,000. Let's keep this separate for now, but we'll start combining it later. So 1 plus 0.04 raised to the number of years. So 5. So now let's go ahead and combine this. So A equals 2,000. And we can start doing this on the first step. I just want you to see where this number is coming from. 1.04 raised to the 5th. And you got to remember your order of operations. You can't multiply and then raise to the fifth. You actually need to raise it first and then multiply. If you plug all this in your calculator correctly, it should handle it for you. And it's going to give you this number, 2,433, and then a big long decimal. Now, we're talking about money here, so we do need to round. So, of course, we're going to go 2 decimal places because that's how many cents we go to. So 30 cents, but we do need to round up. That 5 is going to round it up. So it's $2,433, and instead of 30 cents, it's 31. Now, how much interest have you earned? So this is how much money you have in your account, not how much more you got. This is how much you have now. And so if you look, you put $2,000 in that account. 5 years later, this is how much money there is. So how much have you earned? You need to subtract those two numbers to figure out how much you've earned. Now, that's a basic subtraction problem. It's not always going to be such perfect, nice numbers. So when you subtract those, you've earned, I don't know where I got that number from, $31. I'm sorry, 31 cents. Start over. $433.31. That's how much you've earned in interest. So just remember that this A represents the amount of money you've actually got in the account. So you put $2,000 in, now you've got $2,433.31. So basically, how much did that go up? How much interest did you earn? $433.31. All right, same idea now in number 3. So it'd be good practice at this point if you think you kind of understand that. Pause the video and try it, and then watch and see how you did. So we're going to start with the same formula here. Suppose you deposit $100. That's your principal. In a savings account, it pays an annual yield of 3.25%. So if it was just 3%, that's 0.03. So if it's 3.25%, it's still 0.03 because it's 3%, but then you're going to still have to add on the 2 and the 5. So really, 3% has a decimal right here, and it moves 2 spots. And then you have to fill in that spot with a 0, and that's why we get 0.03. So this decimal's right here. You're going to move it 2 spots, fill in your empty spot with a 0, and that's why we get 0.0325. So that's what we got to put in here. 1 plus 0.0325. And we're going to leave it in there for 3 years. So we're going to raise this to the 3rd power. All right, so first step will be to put this all together, which is just 1.0325. So again, you can start going straight to that. That's fine. And if you were going to use a basic calculator, you would need to raise this to the 3rd first. And let's say you didn't even have a calculator with an exponent button, then you would times this by itself 3 times. 1.0325 times 1.0325 times 1.0325. But of course, if you have a scientific calculator, it will do the exponent for you. So you could raise it to the 3rd, get that answer, times it by 100. And most scientifics and a graphing calculator for sure will let you type all of this in, and they should be able to handle it for you. So this comes out to $110, 703078. Of course, we want to round this. So we're going 2 spots, 7 cents. The next number is a 0, which means we're not going to change it. So it's $110.07. So how much interest have you earned? Well, we now have $110.07. We started with $100. And so we have earned $10.07. Now you might say, well, why would I put $100 in this account, leave it there for 3 years just to make $10? The reason that seems so small is because you're only putting $100 in. If you're putting large sums of money in, and you're making, like this said, $10 on $100, well, if you would put in, say, $1 million, not that we all have $1 million sitting around, but if you did, in 3 years, 10% basically is what you've made. You're making 3.25 per year. That's the annual yield. But after 3 years, $10 is 10% of 100. If you would put $1 million in, you've made $100,000 just having your money sit there. So the more money you can put in and let it sit and accrue interest, then the more money obviously you're going to make. Okay, I want you to do the same thing here with number 4. Pause it. Okay, and then try this and then go back and see how you did. So we are going to use this formula. This time we'll jump straight to the 1 plus the rate. So when Jewel was born, her parents put $2,000 in an account for college. So there's your principal. Principal is $2,000. What will the account balance be in 18 years? That's your T. When she graduates, if the annual yield is 5.4%. So 5% is 0.05. Okay, so we're going to start with that. 5.4%, you literally just add the 4 at the end. Okay, so that's going to be our rate. Now I'm going to go ahead and add the 1 and the 0.054. It's 1.054. Raised to the number of years, so 18 years. Run that through the calculator. 5154 196734. 19 cents, but that's 6. This is going to bump it up. So final answer, $5,154.19 rounds up to 20 cents. All right, and one more quick example. We're going to compare two different things. So which one yields a bigger investment? A 6-year investment with an annual yield of 5%, or a 3-year investment with an annual yield of 10%. Now notice they're not telling you how much the investment is. So you could just make up a number. Let's say you invested $100 and you could put that for your principal on each one of these and run through that equation and see which one's bigger. But we're going to take it and we're just going to leave that P alone and see what happens. So our account is going to equal whatever the principal is times, now it's 5%, that's 0.05. If you add it to the 1 in here, that's 1.05. This is a 6-year investment raised to the 6th. And we're going to compare that to, we don't know the principal, but we're going to have a 10%. So you would think, well, 10% should be a lot more than 5%, right? That's double, but it's a shorter investment. It's only 3 years. So this 5%, you're getting it every single year, 5%, then 5%, then 5% over 6 years. This one, you're getting a bigger chunk year to year, 10%, but it's only over 3 years. So let's see which one actually gives you more money in the end. 10% over 3 years or 5% over 6 years. Or maybe they're the same. And so our 10% is 0.10 or 0.1. And so when you add that to the 1 in the middle, it's going to be 1.10. And you could just put 1.1. And this is after 3 years. So we can raise this here, and we'll just leave the P alone. And so if you raise 1.05 to the 6th, you're going to get 1.3400956641, on and on and on. And we still have that P. We're just going to leave it there on the end. Whatever your principal is, it's getting multiplied by this number. And over here, if you raise 1.1 or 1.10 to the 3rd power, you just get 1.331 P. And so when you go to compare, it's not about which one is a longer decimal, right? You compare piece by piece. The 1s are the same, the 3s are the same, but the 4s, the 4 itself is bigger than the 3. So this is a bigger amount, but not because it has more decimals, but because 1.34 is bigger than 1.33. So when you look at it, this would be the answer to your question. A 6-year investment with an annual yield of 5% is going to give you more money because whatever your principal was, you're going to be multiplying it by this number, as opposed to the second 10% investment over 3 years. Whatever your principal it is, you're multiplying it by this number. Now you can see these are really close. Okay, so this probably isn't that significant, but it all depends on how big your principal is. If you're putting millions and millions and millions of dollars, if you're a huge company investing millions of dollars and you're getting a return on it, this little bit makes a big difference. Okay, so we can compare this by just simply running this through. Again, you could have actually plugged in a principal here to both of them and just seen which came out to more. But here we can just compare that this is the number being multiplied by your principal.